Okay, if you guys struggled at all with 73 from your OTI, this will help. And also the problems in the 50s also had some of the same process. But this just throws in another wrench with the parallel and perpendicular. So find the slope-intercept form. Okay, so solve for y. In the end, that's what they want. Of the lines that pass through this given point, but it's parallel to this line. Okay, so step one, we got to figure out the slope of this line. All right, so where did I do that? Oh, here it is. So we need to solve this for y. Let me zoom in. Move the x term to the other side. Divide by 6. So the slope of this line is negative 1/2. So now I should be able to find the slope of a line parallel to this. Okay, many of you at home too that submitted your OTI online, all you had was the answer from the back of the book. Sorry, no credit every time for doing that. And for you guys here too, of course. Got to show this stuff. Okay, so solve for y, get the slope. Now, using this slope and the point that it passes through, we have to start with point slope form. So y minus negative 3 equals negative 1/2 times x minus 4. And then we solve for y and apply our algebra skills to do that. Distribute. To get this, move the 3 over. Okay, pause for question. Now we got to move on to perpendicular. Okay, so if it's perpendicular to this line, I have to take the negative reciprocal of negative 1/2. So the perpendicular slope has to be 2 over 1. And I'm still using the same point. Okay, so I change the slope and I do the same thing. Jump to point slope form. Y minus a negative 3 equals 2 times x minus 4. Solve for y. Okay, here's the feedback on your evens. Number 12 from yesterday. I said if it goes through the point negative 4, 1, that's where you begin it, and show a line that has a slope of positive 1/2. So it should look like this. Here's your slope of 3 line. Your undefined means it's a vertical line, so it goes right through that point. Here's the negative 3. Okay, so that's what it should kind of look like in the end. 24. They asked us to give the slope and y-intercept, so solve for y to get this. And then use that to get a graph, right? Label your axes too, at least some tick marks. Otherwise, can't tell how high you went. So down 2, over 1, 2, 3. This will probably be your next coordinate if you're using that method. Okay, 24. 32. 32. I guess they just said find the slope or something on here. So find the slope, negative 5/2, and then get a graph going. You can just plot the 2 points they give you. It's the quickest way to do that. Okay, those are the only 2 evens. Let me skip ahead to something in the 50s. You know, they're asking us to write an equation of a line, and so we should be using point slope form here. So for example, 53. They gave us some decimals, that's okay. They gave us a slope of 5, and they gave us a coordinate. So plug them in. Distribute the 5, gives me this. Okay. Then add the 1.8, it gives me the final answer. Okay, we can't just jump to the final answer from the back of the book. We need to show how we get there. Okay, that's a high y-intercept, so I guess it's up to you how you decide to graph it. And you can go up to y-intercept to 27.3 and then do a slope of 5 over 1. Or you can plot the point they give you and try to do a slope of 5 over 1 from there. The graphs aren't usually that far off the coordinate plane, though. You know, it might be a little more typical, like 55. 55, they didn't give us the slope. So just like our notes and in the video, we got to find the slope first. So once you get the slope, plug it into point slope form right here. Negative 3/5, and then choose one of those points to plug into point slope form. And solve for y. Okay. All right. 51 was kind of unique because it had a slope of 0. Somebody asked me that when I walked around. So if it has a slope of 0, you can still use this. 0 times this whole quantity is 0, so it wipes it out. add 5 halves, and that's what we get. Y equals 5 halves, or maybe you wrote y equals 2.5. So we have a horizontal line at y equals 2.5 for 51. That's another good quiz-like question right there. Okay, 73, I kind of already addressed with the warm-up. Just like it, though, you got to make sure you use point slope form for each of them. Solve for y first. And 77 was a little unique. So let me finish here by talking about 77. So watch this one here. All right, we got to write the equation of a line that's parallel to this one. Well, this one is a horizontal line. So a visual aid for this is probably going to be the best way around this. So if I were to graph y equals -5, 1, 2, 3, 4, 5 down here, here's the graph of y equals -5. Okay, so how do I come up with an equation of a line that's parallel to this one for part A, and it goes through the point -2, 4? Well, let's plot -2, 4. 1, 2, 3, 4. So it goes through that point, but it has to be parallel to this. Well, if it's got to be parallel to this, then it's got to be another horizontal line. Okay, so what's the equation of this line? It's y equals 4. See, I'm going through at y equals 4. All right, so for this one, which is kind of unconventional, you might just want to get a graph going to figure it out. Point slope form might not help you as much on this one. It could, because you can throw in slope of 0 into point slope, but you can't for undefined. So part B, you'd really want this graph. Okay, so for B, it's going through the point -2, 4, and it's got to be perpendicular to this line. So they're talking about this line. Yeah, come on, draw straight. Okay, so what's the equation of the line I just drew? X equals -2. Okay, you can see it now, right? All right, so it gets a little messy with the horizontal vertical lines because, like I said, you can't plug an undefined into like point slope form right here. That would give you an error message. You can plug in 0 there, but you can't throw an undefined. So draw a sketch, okay?